Hello, this time Kirchhoff's laws applied to AC circuits level 1. And at level 1 we get not only 180 degrees and 0 degrees, we can get 90 degrees and minus 90 degrees as well. And when you start getting more than just 0 and minus 180 or plus 180 degrees, you really have to start using the complex numbers to solve these problems. But in a way that actually gets easier, provided you've got a calculator able to deal with complex numbers, and at level 1 you have. It's just exactly the same technique as we used in DC circuits. The total current flowing into that node must equal the total current flowing out of that node. Therefore, the unknown current here, plus this current, 10 milliamps at minus 90 degrees, must equal the 21 milliamps at 180 degrees. So I could write that as 21 milliamps at 180 degrees minus 10 milliamps at minus 90 degrees, and let the calculator sort it out. The answer, 23.3 milliamps at 155 degrees. Next, same idea, total current flowing into this node must equal the total current flowing out of this node. The total current flowing into this node is 7 milliamps at 0 degrees plus 2 milliamps at 90 degrees, and the result of those two is 7.28 milliamps at 16 degrees. If we wanted to think about that in terms of a phasor diagram, we'd have something like this. 7 milliamps at 0 degrees would be a phasor along the real axis to there, and 2 milliamps at 90 degrees would be a phasor up the imaginary axis at an angle of 90 degrees to 2 milliamps. The phasor sum of those two would be that point here. And if I draw that line in, you should find that the length of this phasor is 7.28 milliamps, and the angle is 16 degrees. We could actually check that. This is, after all, a right-angled triangle, and we know this side is 7 milliamps, and this side is 2 milliamps, and therefore the hypotenuse would be given by the square root of 2 milli squared plus 7 milli squared, and pressing a few buttons on a calculator, actually I could show you, square root of 2 squared plus 7 squared is 7.28, so the result there is 7.28 milli, and the angle here we could work out from the arc tangent of 2 divided by 7. And the arc tangent of 2 divided by 7 is 15.94 degrees, approximately 16 degrees. And that's just what the complex calculator in the quiz app is doing for you. If you didn't have the complex calculator, you'd have to do it this way. Find another one. Another one. This time both of the phases are 0, so that makes things extremely easy, and you could type in 11 milli without thinking very much, get a very quick time and more points. A voltage one here. And again, just apply the same technique. We know that the total voltage from this point on the circuit to this point in the circuit must be the same. Therefore, 21 volts at minus 90 degrees must equal the unknown voltage plus 10 volts at 180 degrees. In other words, the unknown voltage is 21 volts at minus 90 degrees minus 10 volts at 180 degrees. Answer, 23.3 volts at minus 6.5 degrees. If we were trying to do that one on an Argand diagram. The kind of thing we would have in this case is, well, the voltage here, the total voltage, is 21 volts at minus 90 degrees, so it would be down here at minus 21. That's the phasor representing this voltage here at minus 90 degrees. Then the phasor representing this voltage source here, 10 volts at minus 180 degrees, that would be this way. Straight back like that, 10 volts to minus 10 volts there. And what we want is the voltage here, which if added to this voltage here, gives me that voltage there. In other words, this one is this one minus this one. And this minus this, well, to subtract a phasor, you go in the opposite direction, but the same length. So we would go in that direction, a distance of 10 volts to that point there. And in Cartesian coordinates, that point there would be 10 minus 21. I could write that point as 10 minus 21j. But in terms of polar coordinates, its length is from here to here, and this again is a right-angled triangle. The length of this phasor is 21 volts. The length of this phasor is 10 volts, so we can work out the hypotenuse. The length of the resultant phasor here is just the square root of 21 squared plus 10 squared, which is 23.26. And the angle here, well, that we could work out from this triangle here. It's the arctangent of opposite divided by adjacent. The opposite is 21, the adjacent is 10. So arctangent of 21 divided by 10, about 64.5 degrees. So this angle here is 64.5 degrees. But we're going clockwise to get from the zero phase down to this phasor here. So that makes this phasor 23.26 at minus 64.5 degrees. And that's how I would work out the answer if I didn't have a calculator that could do complex numbers. Right, I think that's about all you need to get pretty good at level 1.